Today we're going to continue reviewing derivatives, and we're going to start looking at the derivatives of particular types of functions and finding those derivatives analytically. Now these are things you would have learned in Math 108, but we need to review these things before we get to some more advanced derivative techniques that are coming soon. So the first type of function that we're going to look at is the power function. So what is a power function? A power function is just some variable base raised to a constant power. Okay, so for example, x squared, right? X is a variable and the power would be 2, right, for x squared. So that's an example of a power function. Now we can do x squared, x cubed, x to the 500th power. We can also do functions that can be rewritten as a power function. For example, the square root of x. The square root of x is x to the 1/2 function, or x to the 1/2 power, right? So, so we can rewrite square root of x as a power function. The same way with 1 over x. 1 over x can be written as x to the -1, so we can rewrite 1 over x as a power function, and then we can use the power rule to take the derivative of it. All right, so let's get started. What does the power rule say? The power rule says that the derivative of x to the n, so variable base raised to a constant power, is just n times x to the n minus 1, right? So we essentially bring the power down, and it becomes a multiplier, and then we subtract 1 from the power, from the power. All right, so so let's take a look first of all at x to the 5th, right? So x to the 5th, right? I can write f prime of x. That's the derivative. This is a new function. It's not the same as the original function. This is now the derivative of the function. So it's going to give us the slope of the tangent line at any given point, right? So so how do we take the derivative of x to the 5th? All right. So our n is equal to 5, right? This is n equals 5. So we bring down the power. We write 5 x to the n minus 1. So 5 minus 1 is 4. So that's it. The derivative of x to the 5th is 5x to the 4th. Okay. So there are some special cases of the power function. For example, the derivative of a constant. You can sort of think of it as so here we have a constant k, derivative of k. So k is just a number. It's just a constant. So the derivative of a constant function, we could think of that as a power function because we could write it as kx to the 0, because x to the 0 is just 1, right? So, and if we apply the power rule to it, we just get 0. So the derivative of a constant is 0, which makes sense because the function y equals k is just a horizontal line, which the slope is 0, right? So it makes sense that the derivative is 0. Also, just x, plain old x. It doesn't look like there's any power there, but it's the same as x to the 1, so it is a power function. So you bring down the 1 and then subtract 1, so it's 1 times x to the 0. X to the 0 is 1, so the derivative of x is just 1. All right, so let's look at this next one. We have f of x equals 6. So this is a case where we're just taking the derivative of a constant. So k is equal to 6, right? If you graph this function, it's just a horizontal line. So the slope is 0. So it makes sense that the derivative is 0. So we can write f prime of x is equal to 0, right? All right, let's scroll down here a little. All right. Now, sometimes we have to rewrite a function as a power function, right? So I think I mentioned this already. I can rewrite this function as x to the 1/2 power, right? And now I can apply the power rule. Now make sure that you write specifically that this is g prime of x. This is no longer g of x. This is g prime of x. This is a derivative function. All right, so we apply the power rule. We bring down the power, which is 1/2, and then we have x to the 1/2 minus 1, which is a negative 1/2. That's all there is to it. So that's the derivative of the square root of x. Now I can rewrite this. Now this is fine. I don't think you have to simplify these derivatives. But this is actually the same as 1 over 2 square root of x, right? Because this x to the negative 1/2 is 1 over the square root of x, and then it's times 1/2. So I could rewrite it this way, but you don't need to. You can just leave it. Don't. In fact, it's probably better not to simplify unless there's a reason to. Okay? All right, here, this is another one that doesn't look like a power function, but we can rewrite it as x to the minus 1. Now it's a power function, so the derivative, h prime of x, is equal to minus 1. So I'm just going to say minus 1 times x to the, and I'm going to subtract 1 from the power. So it becomes x to the minus 2. All right, that's it. You can leave it like that, or you can rewrite it as minus 1 over x squared, right? Because x to the minus 2 is 1 over x squared. So you don't have to simplify unless there's a reason to, though. All right. So, and this is, I'm going to say, I want to emphasize again, make sure that you write the derivative of a function is separate. So I've seen people, they'll just say this is equal and then they'll write the derivative, but that's not that. Make sure you make sure that you show me that this is a different function. This is now the derivative. All right, so now this, I'm just rewriting the function. I need to rewrite this function. I have the cube root, which is a 1/3 power of x squared. So I can rewrite that as x to the 2/3. All right, now that is the same function. That is p of x, just written in a different form. Now I'm going to find the derivative of the function. All right, this is a different function now. I'm going to find the derivative of the function, bring down the power, right? And then subtract 1. So when I subtract 1 from 2/3, I get a negative 1/3. All right, leave it that way. You don't need to rewrite it unless there's a reason to, and there's no reason at this point. All right, now this is another one where I have to rewrite it. Now I can think of this as, this is equal to t to the 1/2 over t to the 1. And then I can subtract the powers, right? I have the same base of t. So this is actually the same as t to the minus 1/2, right? Because I have a quotient. And I can subtract the powers because they have the same base. Now it looks like a power function, so I can say that k prime of t is equal to, we bring down the power, negative 1/2, and then t to the, I gotta subtract 1 from that, so it becomes 3/2, right? Because it's negative 1/2 minus 2/2, which is negative 3/2. All right. Be careful when you write these too, because I see a lot of times people will write, especially when you have a fractional coefficient, people will write 1/2 t to the minus 3/2. I don't like that because it's kind of looks like this 2t to the minus 3/2 could be in the denominator. Make sure it's clear that that 1/2 is the coefficient, the negative 1/2 is the coefficient on t to the negative 3/2. Okay, so if you write it like that, it's not clear because it almost looks like this could be the denominator, and that's not the case. So just be careful when you have fractional coefficients. So same way over here, don't write it as 2/3 x to the minus 1/3, because again, it's not clear whether that whether you meant for this thing to be one denominator or not. So don't write it like that. Make sure it's clear that it's the coefficient times that power function. All right, so I'll meet you in the next video for more practice with derivatives.